Hey guys, one other requested problem was one like this on 9.4. Um, and this is the one I want to do. It's number 24 out of the book. It says find the partial fraction decomposition for 1 over x squared times x squared minus 2. So we kind of have a combination of things we have to keep track of, okay? Now, first of all, I have a linear factor in x, but it's a repeated linear factor. So for that reason, I have to have a over x plus b over x squared. That's to deal with the x squared right there. Okay, and that should look familiar from one of the previous videos. Plus, now right here, I have a nonlinear factor, but I can't really break it down anymore. So I know that on top of this one, for the x squared minus 2, for it to be a proper fraction, it could have an x up top. Okay, so I have to take that possibility into account by doing cx, but it could also have just a constant, so cx plus d. So this is kind of combining two of those previous ones kind of into a single problem. So this is your setup for this partial fraction decomposition. Okay, I'll give you a little hint. What's nice about this is there's not tons of crazy fractions. The algebra is fairly straightforward. Okay, so now I know that 1 is equal to ax times x squared minus 2, right? A times, to get that common denominator, we need an x and an x squared minus 2, plus b, there I need to multiply that by x squared minus 2, plus cx plus d, and that needs an x squared. That would just be so we could get those common denominators. Okay, now when I multiply things out, I have ax cubed minus 2ax plus bx squared minus 2b plus cx cubed plus dx squared. So I have this thing right here. Okay. Now, from right here, I'm going to go ahead and I'm going to write this on this side as 0x cubed plus 0x squared plus 0x plus 1. And once again, I'm going to equate the coefficients by grouping things up. So over here, I could write this for my x cubed terms, just combining them, factoring out the x cubed, plus b plus d times x squared. So notice I've taken care of my x cubes, I've taken care of my x squareds, minus 2ax minus 2b. So I know that a plus c has to equal 0, b plus d has to equal 0, negative 2a has to equal 0, and negative 2b has to equal 1. So let's write all of these things down. I know that 0 equals a plus c. I know that 0 equals b plus d. I know that 0 equals negative 2a, and that 1 equals negative 2b. Well, it's easy to see from here, a is equal to 0. From here, we get b equals negative 1/2. If I use a equals 0 up here, that means c equals 0. So see, this is coming together really quick. And right here, b plus d equals 0, negative 1/2 plus d equals 0. I get d equals positive 1/2. Nice, quick, easy. Could plug it into your calculator, but why bother, right? So at this point, I can write down my partial fraction decomposition. Okay, so this thing I started with, 1 over x squared times x squared minus 2. If I wanted to write it as separate fractions, that would be, let's see, a is 0, so I have nothing over just an x. B, that was negative 1/2, so I have negative 1 over 2x squared. Once again, that came straight from just putting b in here. C is 0, so I have no cx plus d. Well, d is 1/2. Plus d, that's 1/2, and that's over the x squared minus 2. So there's that partial fraction decomposition for that problem. That should be similar to possibly a tricky problem in the My Math Lab. But, any other questions, please don't hesitate to shoot me an email.